So, hello everybody. I welcome you to our webinar today about round robins and proficiency tests in XRF. My name is Rainer Schramm. I would like to present you a bit our process and the requirements and our experience with round robins we made over the last 12 years. And I also try to answer the questions, why should you contribute in one of our round robins? First of all, I would like to explain you the procedure of a round robin. Then I have to talk a little bit about some statistical basics, like the precision, reproducibility, trueness, what is a reference value, and what is the purpose of a round robin. And of course, what are the requirements for a round robin sample. And of course, I will give you also some examples how to evaluate a round robin. So our experience over the last 12 years was made with mainly materials for the analysis of X-ray fluorescence. So the materials we analyzed was something like cement, refractories, continuous casting powders, feldspars, limestones, iron ores. Also, we had some catalysts in between, but all these materials where the focus was on analysis with X-ray fluorescence, and this is our main experience, and this is what I want to talk about today. When we start with the round robin, the first thing is the blending, and this is the most important part. Which where many time is also used to choose the samples, because the samples must be available. For example, it's coming from a customer who would like that his production sample should be part of a round robin. But then also we have to find other laboratories which have an interest in these kind of samples, with the elements in a certain concentration range, so that this all fits together. Then, of course, such a sample must also fit the needs that it can be used in a round robin. This I will explain also later, what are the requirements there. So when really a sample was chosen, then, of course, we communicate this, we do some advertisement, we put it on a website, send it in a newsletter, in our newsletter to you, so that you have a chance to do a registration and show your interest in participating in such a round robin. Then, of course, you will get an invoice to cover a little bit the costs of this round robin work. Then we have to create it in our round robin software. We use there a special software where also it makes sure that all the evaluation procedures are up to date. And once this was done, one work will be to create the material safety data sheets, the labeling, what is the name of this round robin sample. We have to set up a cloud platform where you then find all the documents. We have to inform you that the sample will be ready for shipment. And of course, you will also get clear instructions what you have to do in this round robin, where is the focus, what elements, what methods we recommend. This will be all distributed to your place. Then after a certain while, you will send us your results. And then the first thing is that we check all these results on plausibility. That means any kind of blunders which makes no sense, typing errors, mixing of data, all this has to be identified. And if necessary, we will contact you and discuss with you where could be the problem. Then we do our statistics. We will issue a preliminary report, which again gives you the possibility to intervene, to say that something was going wrong and your results were done under different conditions, so that we can fine-tune the round robin in a way that in the end it really represents the measurements you did and the goal you had in mind when you were participating. Yeah? And also when we blend the round robin, so that the final so that the goal we had in the beginning is really fulfilled. And then in the end, you get a final report and, of course, a certificate of participation. So let me start with a control chart, which so that I can use this a little bit to explain the statistics and all the parameters. If you use a control card in your laboratory, this means that you measure the same sample and one parameter every day, and then such a contribution of measurement values will appear. The mean value is here as the main line in the middle, and you will have this noise of your values. Then the first thing you can do is you calculate your standard deviation, and then normally 2 times the standard deviation are the green lines. That means this is the warning level. So all values within that range just tell you that the method is okay and working fine. Our values in between this warning level and the red one is the 3 times standard deviation. These are then the intervention level. Then if it's outside, you really have to do something, and then your method is not working okay anymore. In between, this is a kind of a warning region where you should observe your method, and if there's more than one value after the next, then of course you need to do some action. So the first parameter I want to explain is the repeatability. So this is the standard deviation of your repeat measurements, and it is assumed that you use the same test method, same sample, same laboratory, same user, same measuring device. So everything is kept constant, and then you get a certain distribution of your values, which could have a very high repeatability or a very low repeatability. This is nothing else than the standard deviation of your values. In contrast to this, we can say that we compare now values from different laboratories. Then we are talking about a reproducibility. And this means then the parameters are not kept constant. You have different laboratories with different users and different machines, and perhaps even different methods. So in this way, the error will be higher, and this we call then reproducibility. The next thing will be the trueness. The trueness is the mean value of your measured of your measurements, and then the distance to the certified value or the reference value. While just for comparison, because this is mixed very often, the accuracy is just a single value, the difference to the reference value. So this trueness is also called bias, just as information. So coming back to the control card, now the big question is, if you establish a mean value in your laboratory, how does this compare to a third party? That means when you compare to a reference value from outside, and the difference will be the trueness, how can you establish this? And there you have to understand also how XRF is working, because an XRF instrument is giving you only an intensity, and the intensity becomes a concentration over the calibration function. So the calibration will define what you measure. And then it's a big question, how did you do the calibration? And normally there you use certified reference materials, and in this way you have a relationship to a third party outside of your laboratory. And this is not always the case. So the certified reference material gives you one possibility, or a round-robin study will be a second choice to establish a relationship to outside of your laboratory to test your trueness. But sometimes even that is not possible. So you have no certified reference material available, you have no round-robin study which is offered somewhere. Then what we then do is just a simple laboratory comparison. That means you exchange a material between 2 laboratories, both do the measurement. And this is the simplest way to do a laboratory comparison if nothing else is available. But a round robin, of course, has a much better statistic because more people are contributing. So the value and the security is much higher then. So, but there are different purposes of round robins. So the first thing, and that's what I'm talking about today, is to test the trueness of a laboratory, which is also called a proficiency test. But also when you are sitting in a standard committee, sometimes a round robin is used to do a method validation, to check a test procedure. Or another possibility would be to use a round robin study to establish a certified reference material. The references or the standard methods where this is described is this ISO 17043. This is how a round robin has to be organized and what are the conditions for it. To do the statistical evaluation, we use the ISO 13528, which also explains the use of robust statistics. Or in Germany, we have also a similar kind of method. There are other ISO methods which explain, for example, how to do the method validation, but this is not part of my webinar today. So we are just looking about this trueness from your results you do from the round robin samples to the mean value of the whole study. If we look on the material, there will be some requirements. First of all, it must be homogeneous. Then it must be stable over the whole time of this procedure. And it should be suitable for the test method we want to use it for. And if it's really stable for a long time, it could be also a candidate for a CRM we can then produce later on. And this is what we do normally, that we use such a material to establish also a certified reference material later on. But then we don't use the round robin results. We will do an own kind of method. But now let's have a look on results of a round robin study. My example is phosphorus in cement. And what you see here is that the laboratory values were sorted from the lowest value to the highest value, so that you get this nice kind of order. All the laboratories are coded so that you don't know who it is. And you will see the single values the laboratories have given to that study. Then we distinguish between two types of values. There will be informal values, which come from methods which are not traceable. And we have values from methods which are traceable. This is important because we want to calculate the mean value only on values where we know that they are traceable, for example, to a certified reference material. And therefore, we always check with you what method you use and what sample preparation, so that we are sure that your values are traceable. But we also offer that you can contribute in our round robin studies with methods which are not traceable, but then these values are not used for the statistics. They're just shown in the graphs, shown in the laboratory evaluation. So you will see how you perform, but it will be not used to calculate the values. Here in this case, it was asked to provide two values for each laboratory to calculate then the mean value of the lab. So this was not used for calculation. And then the first value we establish is the mean value. And the mean value is calculated from the mean values of the single laboratory. And then it's the mean value over all mean values. This is then established. The second value, what we will calculate, is the repeatability standard deviation, which is nothing else than the repeatability from the laboratories, so that we see how is the distribution in the laboratories. And the third value is then the reproducibility standard deviation. This is then the variation between the laboratories so that we see how it performs overall. If you look on the values, in this case, you will see that the reproducibility is always higher or mostly higher than the repeatability. This is like I explained to you in the beginning. Here you have only one laboratory which uses perhaps the same user was doing the test. Here we have many laboratories with different methods, different instruments. So this is why then the error normally is higher. So there's another parameter we have to discuss, and this is the Z-score. The Z-score is defined as one reproducibility standard deviation, and this is then used to check how you perform in this study. And the red lines you see here, this is 2 times the standard deviation, 2 times this reproducibility standard deviation from the mean value. And within this, you see that all these values are marked blue. So Z is then 2, and if Z is below 2, we call this a satisfactory result. In another example I show you here, this is calcium oxide in cement. You see now that we have values marked orange, and this means they are in between the red line, 2 times the standard deviation and 3 times the standard deviation. Yeah? So here we say that the analysis is questionable. So this is this warning signal I discussed already in the beginning. And if you are outside the 3 set, then it is an unsatisfactory result, and there is an action required. That means when you contribute in a round-robin study and you get Z-scores which are higher than 3 set, you really know that it was not performing. So you have to check what is going wrong. What is the reason for that? This is also true for the yellow. The blue ones are within the satisfactory range. This is a different way to show these Z-scores. And here then you can see more than one parameter. So one laboratory can immediately check all the blue values are within the 2 set. The warning levels, this is between 2 and 3, and the reds are outside of 3. So then you know immediately how you perform. And when you have more than one sample, you could, for example, check if always the potassium is too low. So you might have there a systematic error in your analytics. So this you can see then easily from this kind of presentation. Now I have to explain something about the statistic. So we use robust statistics, and I'm sure that many people just don't know what this means exactly. And that's why I made here a very simple example to explain you what means robust statistics. So here I have an example where 5 laboratories just made 5 measurements. And I think everybody will find it easy to calculate here a mean value. But now I ask you not to use the mean value, to use a median. A median is calculated by sorting these values, that the lowest value is on top, the highest value is on the bottom, and then the median is the middle. So it's a geometric middle. And you see here we have the value 10. If it would be that you have 6 values, then you just, and it would be the middle between 9 and 10, you just take the mean values between the 2. Yeah, so this is the way how the median is calculated. It's not calculated, it's from sorting. Yeah, it's the position in the table where you take the median value. But now let us assume that one of these values is an outlier. So not 9, it was 3. Then you see that our mean value changes drastically. While if we again calculate our median, it doesn't change. So this is something I want to press here, to underline here, that a median is not so sensitive to outlier values. And this is called a robust mean value. So this is the way why we want to use robust statistics to be less sensitive to outlier values. And this is why we use these kind of methods. Robust statistics are also very good when the number of participants are not so high. And to be honest, we normally have something like 10 to 20 to 30 people are contributing in our round-robin studies. And for statistics, this is not a high number. And that's why robust statistics are working very well here. Yeah. And let us assume such an example. We have here 15 laboratories which contribute, and we already see 4 values, which is something like nearly 1/3 already, which could be outlier. And this is what they say, that robust statistics are robust up to until 1/3 of outliers. So you just can leave them in the set, and they will not influence drastically the mean value and also the other statistical values. And that means we will calculate then the mean value by robust statistics, the repeatability standard deviation, and the reproducibility standard deviation, and the Z-score. And what we use is the calculation according the ISO 13528, and it's described in Appendix C how you can use robust statistics. That's what we use. And in detail, it's the Humble estimator for the mean value and the Q method for the standard deviation. But finally, if you want to use these results in an accredited laboratory, then it will be important that the reproducibility standard deviation is converted into uncertainty. And not all round robins will state this. And this is why I introduced here this sheet. I know it's quite a few mathematics here and calculations, but you can just store this away. And when you contribute in your next round robin study, and you need to calculate the uncertainty, you can use this. So let us assume we have in our round robin this kind of reproducibility as our standard deviation. The mean value was 62.078, and your laboratory had this value. Then with this formula, easily you can just calculate from the SR the uncertainty of this standard deviation. When you know the number of laboratories which were used for the calculation, I just calculated for you. And then the second value you need to calculate is the relative trueness. And this is just your value, your mean value from the laboratory, and the difference then to the mean value of the round robin study. And so relatively, you calculate your bias or your trueness. And I just put also you an example here. And then you combine both together to get the uncertainty of the trueness from this round robin study. And in this way, then you have here U bias. For the round robin study, you contributed. If you contribute in our laboratory study, this is already given. So you can just take this value right away. And this is important when you want to calculate your uncertainty in your laboratory using a round robin sample as a reference. If you would use a certified reference material, then of course you can have a look in the certificate, and also this value then for the CRM is given, and then you can use that one. But for the round robin, you have to calculate it or you have to take it from the study result. So if I do the resume of this webinar, I can really point out that planning is the key. So over the years, we made quite a few experience what we should do and what we should not do. And I think the selection of the material is very important. And there we are always open for any ideas from your side. So if you have an interesting material, just contact us, and we will see if we could introduce this in our next round robin campaign. Also, it is important what we learned, that the method you should use and how you should do the measurements must be described as best as possible, so that every participant really knows what to do. and that we have a high quality of results in the end. There are always new materials around. We also would like to cover trends in the market. So when, for example, suddenly a new element, a trace element becomes important in an industrial material, then we want to take this into the next round-robin study. So if you know there's something, you can always give you some information. And also for your side, you have the possibility to review the test methods in your laboratory. And like I told you already, we always try to make a CRM out of such a material in the end, because if it's homogeneous and if it's stable over time, and we have this round-robin study as a third-party opinion, then it makes really sense also to establish a traceable CRM procedure so that we can issue a certificate for the material. So that is another advantage when you contribute in one of our studies. Keep the material, perhaps half a year or 1 year later, then a CRM certificate could be issued. And if you plan your own round-robin, then we are also available to do the statistics or to help you, advise you how to do that. We have done this already for some companies, just as a service. And of course, there is a round-robin coming up from our side. This time we got here from a German steel plant and iron ore, which is quite interesting, and this will be announced soon for a new round-robin campaign. You just have to register in our newsletter, then you will be informed in time. Yeah, and then I just have to say there will be more webinars. So here just the announcement for the next one. And for this one, I say thank you very much.